Welcome to video number 4 on circles. And in the last video, we learned about standard form. Recall standard form was the quantity x minus h squared plus y minus k squared equals r squared. The center was located at the point hk and the radius was r. Now, standard form is perhaps the most useful. Personally, when we're talking about a circle, the main things we care about are where is the center and what is the radius. So in my opinion, the standard form is probably the best and the easiest to use. However, there's another form called general form. And general form, you're going to see a lot next year, and you're going to see it a lot in this section. It looks like this. Okay, so it's ax squared, and a stands for some generic, unknown coefficient, plus by squared. B stands for some unknown generic coefficient, plus cx plus dy plus e equals 0, okay? And in this case, right, we kind of look at it and go, it looks like everything's kind of just multiplied out, right? And what I want you to think about is the analogy of previous things that you've learned in math, right? Remember when we talked about quadratics and you were in Algebra 2, and you saw that quadratics had a standard form, and they had a vertex form, and they had an intercept form. Each of those forms was useful for different things. And so with circles, it's kind of like the same idea. We have a standard form, and we have a general form. And they're both mathematically equivalent, but they're just useful for different things. Okay, so one of the things we want to learn how to do is convert from standard form, okay, to general form. And this is similar to when you were in Algebra 2 and you learned to convert from y-intercept form of a quadratic into standard form, right? So let's take example 1 from the last video. So let's say we had x minus 1 squared plus y plus 3 squared equals 4. And we saw this and said, hey, that's in standard form. To convert to general form, we just have to multiply this out. So let's do that. Let's be very careful to follow the order of operations. Please do not do any illegal math, right? The quantity x minus 1 squared, the exponent is telling me how many times to multiply the base, so make sure you write that out. And let's just see if we can put this in general form, okay? So if I multiply this out and I distribute, this is going to be x squared minus 2x plus 1. This is going to be y squared plus 6y plus 9 equals 4. And once I've multiplied it, my job now is to just rearrange the terms so they're in the correct order. So first up, I need my x squared term. So I'm going to put that first, and I'm going to cross it out so I keep track of what I'm doing. Next, I need my y squared term. That's here. Okay. Then I need my linear x term, which is right here, negative 2x. I then need my linear y term, plus 6y. And then finally I need e, but e is just a constant. So let's just combine all our like terms, right? 1 plus 9 is 10, but I'd have to subtract 4. So plus 6 equals 0. And this here is the general form of the equation of a circle, which is mathematically equivalent to the standard form. So what I'd like you to do is I'd like you to pause the video or wait till the end of the video and on Desmos carefully graph both of these, okay? You will notice they are the exact same circle. One last note, if you randomly saw, this equation, right? The key thing you want to say to yourself is, hey, that must be a circle. And how would you know this is a circle if you just saw this equation? You would notice that it would have the characteristics we talked about earlier. The coefficient in front of the x squared term and the coefficient in front of the y squared term, not only do they match, right, they're both 1, but they're both positive. I will see you in the next video.